Good evening, students. Already we have studied the determinant chapter with theoretical concept as well as problems based on it completely. The last one unit, consistency, inconsistency, and solutions of linear equations have been deleted due to COVID. So, up to what I have completed, that is the entire portion covered in determinant chapter. And also homework problems given, and in next week we will give again the homework problems on determinant. Now today we shall begin with a new chapter, that is probability. In Kannada it is called by the name of Sambhavaniyate. You know very well, in the previous class the probability theory first was discovered by James Cardan, who wrote the first book on the subject of probability. Later on in the 17th century, B. Pascal and D. Fermat were laid down the foundation to probability in the vital sense. Again, the subject of probability is of vital importance in these days, and it is being applied in the almost all branches of science and technology. The foundation of this subject were laid down by mathematician Fermat and B. Pascal in the 17th century while solving the number of problems on the probability. In the 19th century, in the 20th century, a Russian mathematician who developed the probability theory with all details of the synopsis and problems. To understand this theory, we should know some basic concepts of the probability terminology, like as random experiment, sample space, events, types of events. There are three types of events: impossible event, simple event, compound event. After that, tree diagram, and thereafter the algebra of the events. In algebra of events, complementary events, mutually exclusive event, exhaustive event, the event A or B, the event A and B, the event A but not B, in this manner, all the basic concepts of the probability studied in the previous class. After this, again, you have studied the probability of equally likely outcomes and axiomatic approach of probability, classical approach of probability, and some problems we studied in the earlier class. If you know very well all these terminology, then the second year probability will be very easy to understand and solve the problems based on it. Am I right? Is it clear? Welcome back. In the second year probability chapter, we shall discuss the important concept of conditional probability of an event given that another event has occurred which is helpful in understanding the Bayes theorem, multiplication rule of probability, and independent events. We shall also learn an important concept of random variable and its probability distribution, and also the mean and variance of the probability distribution. But according to the Government of Karnataka PU board, due to the COVID problem in the probability, the two important concepts have been deleted by the PU board: Bayes theorem, mean and variance of the probability distribution. Already you know in the revised syllabus concept which has been sent to your WhatsApp group. You check it. After the mean and variance of probability distribution, another one important probability concept is there, that is a discrete probability distribution, that is called binomial distribution. But to understand all these, throughout we have to take the random experiments and events. Now, on the basis of relationship between the probability of events associated with the discrete sample space, addition rule, axiomatic theory, classical theory, equally likely outcomes studied in previous class. And also, we have discussed the methods of finding the probability of events. Let us see. If we have two events, is the occurrence of one of the event affect the probability of the other event? Can you answer please for this statement? Let us you try. This has been studied in the conditional probability. In this conditional probability, consider the experiment of tossing of 3 fair coins. The sample space S is given by H, 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 HT, H, HHT, THH, HTT, THT, TTH, TTT. Hence, the sample space of number is equals to 8. Let E be the event, at least 2 heads appear, and F be the event, first coin shows tail. Then the event E equals to, what is the event E defines here? At least 2 heads appear. Means from the group of sample space we have to select the 2 heads appears in a group of event E. HHH, HHT, HTH, THH. Here 4 outcomes belongs to the event E. In the F event, THH, THT, TTH, TTT, that is the first coin shows the tail in this. From the group of sample space, we have to select F event. Hence, by observing these two events, therefore, probability of E is given by, for individual probability HHH, probability of HHH, probability of HHT, probability of HTH, probability of THH, hence 1 upon 8, because total sample space, total number of the sample space is equals to 8. Hence 1 by 8, 1 by 8, plus 1 by 8, plus 1 by 8, that's equals to 1 by 2. Am I right here? Yes. Then, similarly, we have to find P of E is equals to P of THH, this is T, this is T, THH, plus P of THT, P of TTH, plus P of TTT. Hence, the probability of THH, this is T, THH is 1 by 8, plus 1 by 8, plus 1 by 8, plus 1 by 8, that is equals to 1 by 2. Am I right here? Then, suppose also then the intersection of E and F. Here, intersection of E and F is given by, see here, THH. With the P of E intersection F, with the P of E intersection F is equals to P of THH, means probability of E intersection F is equals to probability of THH, which is equals to 1 by 8. THH, am I right here? The THH is the common outcome from the E and F here and also here. Am I right here? Then suppose we are given that first coin shows tail, that is F occurs. In F, you check it, all together outcomes are shown first time T. That means, suppose we are given that first coin shows tail, F occurs, then what is the probability of occurrence of E? This question has been arised earlier, but with the information of occurrence of F, their first coin does not into a tail, should not be considered while finding the probability E. Is it clear? Slowly understand. What happens here? With the information of occurrence of the F, according to referring the F, their first coin does not into tail, should not be considered while finding the probability E. This information reduces the sample space from set S to its subset F and E. Here already we have taken from the 8 number of the outcomes of the event S sample space, we have made 2 subsets, one is F and another one is E. The sample point of F means each element belongs to the F, which is favorable to the event E, is THH. Am I right here? Is it clear here? Then the sample point of F, which is favorable to event E, is THH. Thus, probability of E considering F as sample space, that's equals to 1 by 4 here. That's equals to 1. Then, this probability of event E is called the conditional probability of E. That means, here the probability of E is given that the event F has occurred, that's equals to 1 by 4. This probability of event E is called the conditional probability of E. Given that F has already occurred, it is denoted by